In Prince of Persia 1, how exactly can we add more time? How do we control the health of the enemies? Change the opponents or even add more lives to yourself? Well, we can use cheats of course, but that is not fun. Let's dig deeper into the world of binaries and edit the game to our liking directly in the Notepad. Today we are going to reverse engineer this beautiful piece of all-time classic and learn a few tricks about security and programming in general. Let's start with the timer. When we run the game, we immediately see that the prince has 60 minutes to save the princess. There are also ticks running in the background, but you cannot see them directly, so for now let's assume they don't exist and focus purely on the minutes. 60 is 3C in hexadecimal. Binaries are stored as hexadecimal numbers. You can check the playlist in the description if you want to learn more about the basics. We need to find something like int time equal to 60. Well, now Prince of Persia 1 is a 16-bit game. Therefore, I know that in assembly, I'm looking for an instruction like move, word, time, 60. Some guessing is involved here, but nothing massive so far. Actually, let me check directly if there is only one 3C00 in the entire binary. We might get lucky. Well, no, we did not. There are plenty of them. To finish the original line of thought, move, word, time, 60 would translate to the opcode C706 something 3C00. Let me go through those 3C00 findings again and check if any of them are preceded by C706. It took just a moment, but look at this. This looks promising. Let me change it to FF00. Save the file, run the game, enjoy the perfect music. And check this out. Now we have 255 minutes. Great. But let's slow down because you probably have some questions. Such as, how did you know we are searching for 2 bytes when 60 minutes technically fits into 1? And what is that something? The 2-byte size was an educated guess. I would love to give you a more dramatic answer, but that's just how it is. Processors love to work with variables aligned to their operational size. A 16-bit CPU processes 2 bytes of data at a time, so the compiler would most likely optimize the variable to 2 bytes, even if Jordan only intended to use a char. And the something, that stands for the memory address. Again, it's 2 bytes, but here is the problem. I have no idea where in the memory the time variable lives, so I cannot search for the address directly. It could be literally anything. So in this case, you really are just scanning through, looking for a structural pattern. Now the health. A very straightforward solution would be running the game in, say, DOSBox X, pausing right in front of a big potion and making a data dump. Then you drink the potion to increase your lives, make another data dump, and compare which bytes changed from 3 to 4. If you are lucky, just 1 byte changes, and that is our guy. If you are unlucky, we can use cheats to make dumps comparing 3 lives versus 8 lives. That change should be unique enough to spot easily. However, we did exactly that in our previous video about reverse engineering Prince of Persia 2, so let me show you something different. Again, we can reuse the idea of searching for the opcode C706 something 0300. However, this time there are plenty of 0300 values. You could go through all of them manually, searching for C706, changing the value, running the game, and hoping you get lucky. Or you can use a more advanced tool, like imhex. It allows you to use wildcards when searching for bytes, basically regular expressions for binary data. You might see where this is going. C706 something something 0300. This translates to search for C706, the MOV instruction, to any 2 bytes address where the value is 0, 3. And just like that, we have it. Now you might be thinking, cool, I know how to change the health of the prince, so I know how to change the health of the enemies as well. Wrong. It is actually very different. An educated guess here would be a real stroke of luck. I'll give you 3 seconds to make up a scenario in your head about how you think this works. For the answer, let's check the official technical documentation. It states, basic strength and basic color are indexed by a level number. So, were you right? Let me know in the comments. Here is the logic. The level summary table lists the levels starting from 0, the demo, and ending at 14, victory. You could try to guess the entire sequence, or we can look for the anchors at the very end. The manual notes that level 14 is the victory level featuring the princess. Since there is no combat on level 14, we expect the value of 0, 0 at the end of the sequence, representing the health of a non-existent opponent. Just before that, level 13 features the final showdown against the vizier, Jafar. He is tough, having 6 lives. So we are looking for a sequence ending in 0600. And how should it start? Probably with 040303. Now, unlike the timer, I would not expect 2 bytes per value here. This is most likely programmed as a simple array, a list of single bytes. There is a modifier applied later in the code, but let's try to search for this raw pattern first. And look at this. This sequence looks good. Normal numbers, 0 at the very end, and the 06 before it, exactly matching the level with Jafar and the one finally with the princess. Let me modify the value that I think corresponds to the first level. And voila! Just a quick reminder. That first 04 is used for the demo level, level 0. So don't be confused if changing it doesn't immediately affect level 1. You need to target the next byte. You know, as always, I must deliberately hide some details or not tell you absolutely everything. But still, you should be able to follow along without too much improvisation. Now, if you can't find these specific sequences in your binaries, or really cannot pinpoint the specific address, take into consideration that there are several versions of Prince of Persia 1 for MS-DOS. And yes, they are different at the binary level. Also, the executable file you have might be packed. This technique was used to shrink the final file to fit onto a floppy disk, essentially to take up less space. If your file is packed, the raw assembly instructions we discussed won't be visible. You might need to unpack it first to see everything clearly. Let's get funky. What if I want to meet the skeleton way sooner than normal? Now, we have to understand the hardware limitation here. Since the enemy shape set, internally called character table, is loaded into memory at the very beginning of the level, all the enemies on a given level must use the same shape set. This is why level 3, skeleton, and level 6, the fat guard, feature no other enemy types. The game literally cannot handle a normal guard and a skeleton in the same memory block. This tells us that we are looking for a specific line of bytes, an array that defines which shape to load for each level. Here are the enemy types we know exist: guard, fat guard, vizier, skeleton, shadowman. We can guess that they are referenced sequentially, perhaps like 0001, 02, 03, 04. There is no reason to know this for sure. The documentation might list them in a totally random order compared to the code, but let's give it a try. I know that the skeleton is in level 3, so assuming the levels start at 1, we can try to search for the pattern 000003. And nothing really looked like a good candidate here. The numbers are off. What I can do is take a wildcard approach. I'll search for long sequences of zeros, because the vast majority of levels just have basic guards, which we assume are 0, and these levels should appear consecutively. Unfortunately, a long string of zeros is way too common in a binary file. Let me try searching for a longer, more specific byte pattern based on the level order. And yes, I have something. The numbers don't match my initial guess perfectly, but let me try to change something here. And nothing happened. What if I try this value instead? But wait, according to my lookup table, I should have gotten something else at this index. Well, never mind. Now we know that the official documentation doesn't respect the ID order used in the code. We can randomly try more values, and there we go. Now we have a skeleton in level 1. Cool, right? But be careful. There is one hidden trap if you want to tinker with this by yourself. I'm keeping it secret as a surprise challenge. Let me know in the comments if you figure out what I mean. Simply try to change guards to skeletons in more levels and see what happens. As a cherry on top, let's try to tinker with the starting level. As we tried before, how about searching for the instruction C706 something 01? Too many hits again. We can be sure that one of these definitely sets the starting level, but finding it manually is a needle in a haystack. You could go and try to change them one by one, but there is a smarter way. Let's go to the game. Dump the memory while in level 1. Change the level using cheats or just Shift L to skip forward. Dump the memory again. Now compare the files and see exactly which byte changed from 1 to whatever level you jumped to. You can also make several dumps and compare them in the same way. The specific byte will simply change according to your actions, allowing you to isolate it instantly. Once you find the correct address in memory, you have two options. You can calculate where the variable lives in the exe file. We call it address translation. Or much easier, you can simply search for the surrounding instruction sequence in the binary file. It's the exact same logic we used for Prince of Persia 2, so I found it here. And let's say I want to start immediately in level 5. Done. Before we end, working with Prince of Persia, I just couldn't resist playing it a bit more. I actually jumped into speedrunning. I practiced for a while and managed to tie the world record for level 1. Take a look. That would be all for today. If you enjoyed digging into the internals of Prince of Persia 1, you should definitely watch this video where we focused on Prince of Persia 2. We analyzed its copy protection mechanism and really got into the weeds of the assembly code. So, if reverse engineering is your jam, you are going to enjoy it. Thanks for watching. If you like what you saw and want to see more in the future, don't forget to hit the subscribe button. Ciao!